Okay, so we have a triangle here in problem number 1 and 2-4. We have that triangle, and they're giving us a little information. They're telling us. So this will be hardly new. You could do this problem, I think, without me saying anything. I think these number 1 and 2, you really know how to do all this stuff. They're telling me angle A is 34.8 degrees. So here's angle A. So 34.8 degrees. By the way, notice how they've set up the triangle. It'll be the same every time. This is probably worth our while for me just to point at it for a minute and show you what I'm talking about. See how the 3 angles are capital letters. Capital A, capital B, capital C. And the 3 sides are small letters, A, B, C. And not only that, see how the A is opposite of the A, and the B is across from B, and the C is across from C? And the triangle, see what I mean? A, on the diagram, A is across from A, B is across from B, and C is across from C. They will always do it that way. Why do they do it that way? They're trying to help you remember that an angle, as it opens up, affects the side across from it, doesn't it? When side B gets bigger and bigger and bigger and opens up, angle B, it affects side B across from it. The bigger angle B is, the bigger side B across from it will be. Angles affect the side across from them, don't they? Their opening affects the side opposite. We'll have a theorem we'll use next week which directly uses that to solve things called the law of sines. So for now, they're just kind of putting in your mind. A across from A, B across from B, C across from C. Okay, so they're giving me capital A, 34.8 degrees, and then little b, so that's a side, isn't it? Little b, down here, 47. So they're giving me one angle, one side. Of course, I know the 90-degree angle. And then they want me to find all the rest of the triangle, the other 2 sides and the missing angle. Let's start with the angle. Capital B, that's an angle.
Minus 90?
Yeah, we take it away from 90. That's right. You aware of that every triangle holds 180? Every triangle, not just right triangles, but every triangle that you'll ever draw or ever see holds exactly 180 degrees. So if that's the case, and the 90, the right angle is already using up 90 of that 180 total, how much is left for the other 2?
90.
The other 90 is left for the other 2, right? So I can find the one up here by taking 90 degrees minus 34.8, and that's going to be, what's that, 55.2 degrees? Yeah, 55.2 degrees, yeah. So this one up here, will be 55.2 degrees. We good so far? So we found the other angle. Now, that's the first thing they want, so that's their first answer here, 55.2 degrees. Let me just get that out of the way there. So we got that. Now, they want me to find little a next. So here's little a right there. You can do this, without me. You know how to do this already. How do we find that little a? Yeah, it's going to involve this angle, little a, and I don't want to use the c yet. Why? Why don't I circle the little c and say, hey, I'll use little a and little c? That's not a good plan, right? Why not?
Because you don't know that value.
Because I don't know either one of them. That'd be 2 unknowns. You don't want 2 unknowns. We ain't going to get anywhere with 2 unknowns. We want to use the little a and the 47. That way there's only one thing we don't know. So, yeah, so you know the trigonometry quite well. So, Katoa. So this is hypotenuse here, opposite there, adjacent there. So what trig relationship involves the little a and the b? Yeah. Opposite and adjacent. Tangent. Good. So tangent of 34.8 degrees is opposite over adjacent, little a over 47. Jose?
Couldn't you use cosecant?
Cosecant. That would be no. Well, not.
No, not cosecant. Hold on. Adjacent over opposite. What's that?
Yeah, that'd work. That'd be cotangent.
Cotangent, okay.
No, I'm sorry. No. Yeah, that'd be cotangent. Yeah.
Could you use that?
You could use that.
Okay.
Yeah. There's actually 2 relationships that involve O and A. There's ones that are upside down of each other, tangent and cotangent. Yep.
The edges shouldn't be negative, should it?
What's that?
The edges shouldn't be negative,
No. No, since these are real sides of a real triangle, they all got to be positive, yeah.
Since it's in degrees, it's usually in radians, huh?
We're in degrees. See the degree symbol?
Okay, so I was right there. Okay.
Yeah, so we're in degrees. So, okay, so how do I solve that for little a? What do you do when you got a fraction on one side? Right, when you got a fraction on one side, what do we do? Now, put this tangent over 1 and go diagonal, diagonal. Cross multiply. We good? So what do we get? 47 tangent 34.8 degrees is 1 times little a. How are we doing? We good to there? 47 tangent 34.8. So then just hit the buttons on your calculator. Make sure you're in the right mode. Make sure you're in degree mode, right? This is degrees, not radians. So 47 times tangent 34.8. I'm getting 32.665. So they want me to round that to 67. 32.67. How are we doing? You getting that? 32.67 for little a. So this side over here. $32.67.
Now, can we just do the Pythagorean?
That's a great question. Everybody good to this point? We all good? We have one more side to find. We'd like to find little c. We need to find. They're asking us to find little c. Now, it's natural to want to do the Pythagorean theorem. The only problem is you can't use a rounded number for a future calculation, or it's going to throw things off. Right? That 32, so if I was to do Pythag at this point, a squared plus b squared is c squared, I'd be using a rounded number. Now, there's an option. You could just use more decimals, and then that'll be fine. If you just, instead of stopping that 32.67 in 2 places, if you use like 3 or 4 or 5, maybe 5 places if you say, and then you'll be able to round the final answer accurate to 2 places. But if you try to use one that's already rounded to 2, your final one won't be accurate to 2. So I think rather than do all that and worry about the extra places, let's just do another trig function. But if you want to use more places and do the Pythag, that'll work. That's okay. I'm just going to go back and just do another trig function. I'm going to say, okay. Oh, I'm going to say, okay, my pencil's dead. So you go ahead and do it. So what you want to do something that involves the 47 and the c. So what is that?
Oh,
Cosine. Cosine. Adjacent over hypotenuse, right? So we want to write out the cosine.
Oh, that's right. Because you don't want.
We good? So let's do that. So I'm going to involve the 47 and the c, and that would be adjacent and hypotenuse. That's cosine of 34.8 degrees is adjacent over hypotenuse, so 47 over little c, adjacent over hypotenuse. Okay, how do I solve that equation for little c? Gonna cross multiply, right? So let's do it. Put this over 1, diagonal, diagonal. What do we get? C times cosine 34.8 degrees is 1 times 47. Last step. Divide by cosine 34.8 degrees. Divide by cosine 34.8 degrees. Hit the buttons on your calculator. 57.24. C is 57.24 is what I got. Y'all get that? That good? Yeah.
So we could use cosine, secant, or the Pythagorean theorem to solve this. Not that you'd want to use any of
Right,
those other
you're
ones,
totally
but-
right, Benjamin. Yeah, that's exactly right. Any of those are possible. Yep, you're right. Well stated. So is that good? How you doing? You want to try one and we'll call it a day? So we did that one all the way out. Questions on that before I move off of it? So there's number 2. So we got the capital B, the little b. So put those on there. Start by finding the capital A angle. See what you can do on that one.
And after you solve for the other angle, you can use that angle, couldn't you, also to solve any of them too?
Yeah, that's right. That's right. That's right. It'll work either way. Oh, yeah, let's see. Sine inverse, sine good. Cosine theta. Oh, I'm completely wrong. I read the top one. That was perfect.
No, I just didn't know what to do right
Yeah,
here.
let me double check.
Oh.
Tangent is x over. Let's put on first.
No.
Tell me about tangent. What is tangent? So the toe.
Stay with
Opposite.
Oh, sorry.
All right, how we doing? Is this making sense? Let's try it. So the capital B is 15.1 degrees. And the other angle, subtract from 90, huh? Here, I'll just put this in like this. 15.1 degrees. Capital A will be 90 minus 15.1, 74.9 degrees. Good so far? 74.9? Yeah, and I'm just going to use that one. Like Pauline was saying, I like the one in the lower corner. But you could use the 15.1, either one. You can use either angle to do your trig angles and make everything work. I'm just going to use the 74.9 and use that to do my trig. So here we go. I need the little a.
I gotta pay attention to where I.
Little a's right there. And I know this angle. Oh, I forgot to put in b. B is 35.5, isn't it? Oops, I'm gonna need that. 35.5. So, what trig relationship involves my angle 74.9 degrees and little a and the b, the 35.5? This is hypotenuse. That's opposite over adjacent. So Katoa, that's tangent, isn't it? Opposite over adjacent. So the tangent of 74.9 degrees is little a over 35.5. So little a over 35.5. Everybody good there? Let me see what I'm doing. Maybe you use the other angle, that's fine. So now I'm going to cross multiply to solve this. Put this over 1, diagonal, 35.5 tangent 74.9 degrees is 1 times little a. Hit the buttons on the calculator. 35.5 times tangent 74.9 equals, I'm getting 131.57 for little a.
You don't have to divide it by tangent, like we did the other problem?
So it depends on the problem. So you just got to do whatever it takes. Did you use the 74.9, Jose, or did you? You did? Right, so look at the way it's set up here. Did you get this relationship?
Yeah.
Right, so when I cross multiply, see how these guys are together and the A is already alone? So I don't need to divide by it. Whereas over here, where was it I needed to divide by it? Yeah, here, look at this cosine one. When I cross multiplied, the C was next to the cosine. So to get the C alone, I had to divide by the cosine.
Got it, okay.
On that. Yeah, good. Other questions on that? That making sense? You guys get the little a? So lastly, so that's the little a. Let me write that in. Bless you. 131.57. Last, we got to get the hypotenuse. So let's get that. So that goes over here. The hypotenuse, now I'm going to restart and I'm going to say, okay, I'm going to use the 74.9, the C, and the 35.5. That's adjacent hypotenuse. That's cosine again. So cosine of 74.9 degrees is adjacent, which is 34.5, or 35.5 over the hypotenuse, little c. All right, I want to solve that for little c. So cross multiply. Yet again, put this over 1, diagonal, diagonal. I get c times cosine 74.9 degrees is 1 times 35.5. Everybody good to there? So I used the 74.9. Cosine is adjacent over hypotenuse. So it's 35.5 over c. Trying to find c. Cross multiply, diagonal, diagonal. Get to there. C, I want to get c alone. So what am I going to do? Here's the equal sign, the wall. C is saying, I want to be alone. What do you do to get c alone? Divide by that cosine, huh? Divide by cosine 74.9 degrees. Cosine 74.9 degrees. 35.5 divided by cosine 4.9 degrees. I'm getting 136.27. 136.27 is my C. Completely solved. All right. Well, why don't we